Okay, now that we have fully explored quantifiers, I want to go back and look at our substitution notation and look at some subtleties that can arise and some mismatch that can occur between what happens when you mechanically carry out a substitution versus what you think we should get from the substitution. So I'll show you what I mean. So remember, this is our substitution notation. If you write a proposition and then a variable and then a term like this, then this stands for the instruction to take the proposition phi and erase any instances of x that you see, and then fill in their place that term that the x's are getting replaced by. Now, let's first try this on a proposition like this. Everything loves y. So let's say this is our proposition. Let me put it in a box rather than in quotes. I think it just looks better. So this is playing the role of phi here. Everything loves y. And then let's look at what happens when you replace y by z. This one is not going to cause problems, but I just want to look at what does work. When you make that replacement, you should get everything loves z. That's how it should work, and that's how it does work. What if I write this symbolically? For all x, x loves y. And then I'm going to go and replace y by z. Then what do I get? For all x, x loves z, which is the same as saying everything loves z. So these match, and I'm happy. But let's look at what happens when we try a different kind of substitution. One where we somehow get the x involved, even though there's nothing really about x going on here, right? X is quantified. But look at what happens when we involve x in the substitution. So there are two ways to involve x in our substitution. Either we can put the x here and replace things by x, or we can put it here and replace x by something else. And in both situations, bad things can sometimes happen. So let's try first replacing y by x. So let's say I make this substitution, everything loves y, and then replace the y by x. So I erase the y and I put an x in its place and I get everything loves x. That's fine. This is good. This is how I want it to work. That should make sense, right? If you take everything loves y and you replace the y's by x's, it should become everything loves x. But over here, if I make the same substitution, even though this is just a symbolic way of writing this, look what happens. I take all the y's and I replace them by x's. This now does not say everything loves x. It says, for all x, x loves x. In other words, x loves itself. This is saying everything loves itself, which is definitely different from saying everything loves x. And this is bad. So now we are unhappy with this. This is bad because it's different. And I mean, we started with just two different ways of writing the same thing, and then we carried out the same mechanical substitution. So it seems like substitutions don't always yield unique results. So we have to kind of decide which one is the correct way to make the substitution. And we declare that this is the correct way to do it. I hope that feels right to you also, that if you're going to have some notion of substitution, then everything loves y should become everything loves x under this substitution. This way of doing it would simply not be consistent. Part of the issue is that it does not even matter what quantified variable I use here. I mean, I could have used, instead of x, I could have used maybe p. And that makes the problem go away. If I wrote for all p, p loves y, then after making the replacement, I would get for all p, p loves x. And, you know, this here is equivalent to everything loves y. And then after making the replacement, I do get everything loves x. So then there's no problem. The problem only occurred because I took the quantified variable and I allowed it to get involved in the replacements. So all we really have to declare for our to avoid this kind of issue is when you're making substitutions, just don't involve the quantified variable in the replacements, or you can really cause a lot of trouble. Right, so I also want to show you that if you replace the quantified variable by something else, you can also lead to weird mismatches there. So so now what's quantified there is p. So if I replace p by y, say, then over here, this should just remain everything loves y, right? Because there's no p's showing up. So it should just stay that way. And this down here should become, well, if I do it mechanically, then I get for all y. So I'm just rewriting the same thing, but replacing all the p's by y. For all y, y loves y. And look, now I'm back at everything loves itself. So this is also bad, and we would say that in this situation, you just can't do the substitution mechanically. You have to pay attention to which variables are being quantified and make sure that you don't allow them to get involved in the replacements. So one way to do it and still be kind of mechanical about things is to just go ahead and, before you make this replacement here, go ahead and just replace the quantified variable by a different one, like q. In all places where the quantified variable shows up, replace it by q maybe. Then proceed with the substitution. Then it'll always work. So there's now I have a good chance to also make this statement about bound versus free variables. So I've been using the term quantified about a variable like p here, which is in front of a quantifier and behind this bar. That's a special example of what I would say is a bound variable. So you could say here, p is a bound variable in this overall expression. And bound means it's not really there for the purpose of the meaning of this expression. So p is bound by the quantifier in the sense that this expression can be written without any mention of p. It's not about p. So this says everything loves y. And the p is only serving as a placeholder to help me say this kind of everything part. So I could replace all the p's by something else and it wouldn't change the meaning at all. So that's what a bound variable is. A variable is bound when it's only sort of serving as a dummy variable in the expression. And replacing it wouldn't change the meaning. Replacing it in every situation, in every instance, by another variable wouldn't change the meaning. So the sort of opposite term to bound would be free. So I would say in this statement here, y is a free variable. Free in the sense that this is really about y in particular. It's saying everything loves y. There would be no way to say this, to write this in English without mentioning y. So bound basically just means quantified for now, but pretty soon we'll have we'll introduce another notation. Let me show you. So here I am in section 3.1, which we'll get into pretty soon, and we'll introduce this notation. And you see the bar is also showing up here. So when we do that, That will also be an example of when we write things like this, which you will see pretty soon with curly braces, you'll see this bar showing up, and this will also be a situation where a variable becomes bound, but not by a quantifier. So what's common among all those situations is that a bound variable is one that's not really there, it's just serving as a placeholder in the overall proposition for the purpose of, saying something, like the everything in the case of this universal quantifier. And that's as opposed to free variables, which are really there. The proposition is about those free variables.